So we're back again, and this time we are going to be working through Unit 2.6 and 2.7. In Unit 2, Section 2.6 and 2.7, and it's all about strings. This is one data type that you're going to use a lot. We read a lot of strings. We work with strings all the time, so let's focus on strings. This one's going to be a little bit longer, and we're going to go through a lot of the pieces of the things we got to know about strings. So let's begin. First of all, a string is immutable. What does that mean? It's unchangeable. Once you've made it, you cannot change it. No, that's not just true for strings. It's also true for integer object, uppercase I, and double objects, uppercase D. So those are immutable. Once you make them, you cannot change them. I know you may be thinking, well, what if I create it again? Like, what about if I do something? Well, you're just creating a new instance, overwriting the old piece of data, but you can't change it. So what you want to do here from here on out is pay very close attention to what I'm showing you about the strings, which methods are your responsibility, which methods are stuff outside this course. I'm showing all, and so that you can focus on it, because a lot of string questions do appear, so we have to master working with strings. Okay, so a string is just an immutable sequence of characters. So it doesn't necessarily mean that the string spells a word. It doesn't necessarily mean that it's something that makes sense. Any characters put together can form a string. So letters, numbers, weird characters, doesn't matter. So what I'm doing here though is I'm going through a string as if it's actually, words that make sense. So we're going to work with that. So the first thing I did is I created a string. There are two ways to do that. I'm showing them here. Well, there are actually more than two ways to do it, but these are the two most frequently used way. We could make them with using arrays and all that. You have to look up the string API to find all the overloaded constructors to see how to make a string. But right now, the string could be made with its literal. So this is making it with a literal. Or it can be made with the constructor. And we've seen this before, so nothing here looks different. However, I'm making the same type of string here. Geometry is a good class. And either I use new string or use the literal. It's fine. This string API that I'm speaking of, the methods that you have to know for the AP exam are listed here. Length, how long the string is, that returns a value. Character at a position I. As long as the I and J in these are within range, they work. Character at a particular spot. The substring starting from I up to but not including J. Substring from the character from the position I all the way down to the end of the string. The index of a particular string or character in that string. Equals, is it equal to another string? For equals, it has to be the same characters in the same order. Comparing two strings. Good for sorting. Comparing strings to see which one comes before or after. Okay, so let's just get down into the one with the index. Okay, so we're going to be looking at the character at I and the index of some particular part of the string. So when you're using these two methods, you got to think like as if it's an array. And if you've never seen what an array is, don't worry. I'm just going to show an illustration here. I have a visualization of it, and I'm using the same string up here, the class description. So what I'm having here now is the G in geometry is at position 0. The E is at position 1. The O is at position 2. The M at 3, and so on, going all the way. Now I want you to pay close attention. Even the space, that's a character. The space in between here is at position 8. And there's another space here at position 11, and so on. It goes all the way through, processing every single character and giving them a number, starting at 0. Computers always begin at 0. The other visualization I wanted to see here is for substring. This one is actually very commonly used, and it's a big topic, so let's pay close attention. It's a half closed interval, if you don't know what that means. In math, you have two numbers. The first number is included, the second number is excluded. That's why you have it half closed. This is closed here, this is open. So what that means is that you don't include j. So if I say substring from 1 to 4, okay, you might want to think like, okay, so 1, 2, 3, 4. This is not the way I want you to think, because you think the answer would be E-O-M-E, which is not true. It says include the first one, 1, and exclude the 4, so stopping at 3. So it'll be E-O-M. Now, to do substrings and only substrings, I want you to visualize them with some bars right here. Okay? The bars occur in between the letters such that you can actually use the values. So for example, just now when I said the substring from 1 to 4, okay, if you look at it here on the substring, you will see it's EOM, because 1 to 4 right there would grab that string, EOM. So it's not that I don't want you to think like an index. I just want you to do this interchangeable type of thinking. For substrings, use some bars between, label the bars, starting at 0 always, and look for the substring that way. So if I say substring 5 through 8, that's the word try, right? 5 to 8 is try. So what we want to do now is just we want to look at what happens when we run a couple of methods, and we have the length here. That should return 24. I know we end at 23, but it starts at 0. Character at 14 plus this substring 20, okay? So this substring has two of them. There's one here that says go from that to the end of the string, and this is start and stop. So character at 14, you want to look up here, okay? Once I'm doing character at, you want to look up here. When I'm doing substring, you want to look down here. So character at 14, we look for the 14th. Okay, that's a G. And if I say class description, that's substring 20, we're looking over here, and that's LASS. Put that together, it spells glass. See, I got a word out of the sentence that I have here. So that's one good thing about strings. You could take a string and you could get extra stuff out of it. All right, so substring 5.8, we got to look down here. So let's see, 5.8 is try, right? And then we're going to add on, remember, concatenating. The substring, this is supposed to be substring, not subsequence. Substring. The code completion puts that in for me sometimes. Don't want that. Substring 3.5. So we got to go back here. 3.5. Try me. That's an angry person. Realize no spaces here, okay? No spaces here. So if I wanted to put a space in here, I could add a space by using substring 13, 14, or I could use character at 11, character at 8, either one. So let me just put that in, just so it could look nicer. So let's put in class description. I'm going to put in a copy here. I'm going to put a character at dot character at 8, because that's a space, and so on. So you could see that I'm looking here now, index of odd. Is there an odd in the sentence? So you look across, look for an O, nope, 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 nope. Oh, there we go. It looked like OOD, not ODD. So what's going to happen here is this is going to return -1. If something does not exist, it returns -1. If something exists more than once, it returns the first one, starting from 0. So O happens at 2, it happens at 15, it happens at 16. This call would return 2, because the first occurrence, we say. Met, let's see if we find the word met. Yeah, there we go. MET, so it's going to return 3. It returns where the thing begins. Equals, it's asking, is the two of these strings the same sequence of characters in the same order? This returns true. And then if we're looking for try, it looks, it spots try right here, it returns 5. If I did substring 0, that returns the whole thing, because remember, a substring with 1 says start there. This is it here. With 1 says start at this point and go to the end of the string, so it's going to return geometry is a good class. And substring 024 is the same thing, right? Because substring 024 is exactly the entire thing. So one thing about this is you could always go one extra, okay? One extra index. If you're looking at them from an array, one extra, but we can't go more than one. What about this 030 here? Okay, 030, if I try to do description, 030, what's going to happen there is it's going to go out of bounds because we stop at 24. 30 is all the way over here. It's going to crash. So I'm going to run that. I'm going to take a look at all those answers that we just went through. Run this. Okay, so we have all the stuff we had from before. But let's just take a look. We got the nans and so on. 24, that was the length of the string. Glass, yes. Try me. Okay, -1, that stuff did not exist. That odd. O was at position 2. Okay. And met was at position 3. We saw it right there. It is true that these two are the exact same character sequence. And substring of 0 is the whole sentence. And substring 024 the whole sentence. And then here we go, out of bounds. And it tells you where it goes out of bounds. So it says 30. There's no 30. Can't go up to 30. So these are the types of things that you're going to be asked to do. I'm going to ask you these on quizzes and stuff. So you got to make sure you know how to maneuver and work with strings. Now, because we could, take a string and do different things with it, that's exactly what we want to check out. So now, if you look here, I have at the bottom about the compare to specifically. So compare to is a very strong comparison because what it does is it compares two strings and it doesn't just tell you if they're equal, it tells you more than that. They're equal if it returns 0. It returns an integer, by the way. If it returns 0, the two strings are the same. If it turns a negative, it means the string that we have in the front, because we always go string dot compare to other, the string that we have in front comes before. And if it turns positive, the string that we have comes after. So it's kind of like bigger and smaller. And if you're wondering, how could strings be bigger and smaller? Is it the length of the word? No. Think alphabetized. Its lexicographical order is kind of like alphabetical order. The reason why I said kind of here is because we're dealing with characters, okay? So characters might not just be letters. Now, most of the time when we're doing a string, it's just letters. That's why I say kind of alphabetical. But if it's not just letters, then there is this ordering that needs to happen. Should the 2 come before the 3? And there's a lot more ordering that happens. So anyway, natural ordering for strings is lexicographical. Now, these strings that I have comparing here are going to be strings that are the same, similar. So hello, uppercase H, starting compared to that. Let's see what would happen. Comparing these two, let's see what would happen. Comparing he with hello, let's run that and let's look for those comparisons. Okay. All right, so let's see. We have some numbers down here. I'll tell you, this is beyond the AP, but I'll tell you where. What they do is they take the characters and using their ASCII gets a code for them in terms of the integer value, and then they do the subtraction. If the two are the same, if the two of them are the same, it returns 0, because if I subtract and they're the same numbers, 0. If one comes before the other, okay, it will be negative. And if one comes after the one in front, so right now the one in front is the hello here. Hello is in front. He is in front. And after. So hello and the uppercase H hello is suggesting it comes before. So you're saying, look, what does that mean? Well, the alphabet is A, B, C, D, all the way to uppercase Z, and then lowercase a, B, C, D. See, that's what I'm talking about, lexicographical. See, in regular English or something like that, you could compare them and put them in order, alphabetical order, and ignore the case. But in computers, we can't ignore case. So the question is, which one comes first, an uppercase H or lowercase h, right? And so that's the lexicographical order I'm talking about here. So it's saying that the uppercase H comes before because it's negative, right? And the up he comes before hello. Let's try and reverse them and you will see. If we do that and run it, now it's staying a positive 3 because the hello comes after he, if you were to put them in alphabetical order. Okay, so that's pretty much what it's saying. If you were to put these in alphabetical order, which one will come first and which one will come after? That's why I said this is more powerful than equals, because we can get an equal out of it, but we could also know where they go in the alphabet, which one comes first, which one comes after, if we're alphabetizing them. So like if I had a list of names and I want to print all the students by last name in alphabetical order, perfect method. All right, the next thing we want to do is to check out some other methods, because the AP has a subset, we call that. It's just some methods that you have to be able to use, substring being a big one, index of and character at and compare to and stuff like that. But there are some other neat ones. So let me show you the ones that are not on the AP exam, but good to know. For example, the 2-character array. Turn the entire string into an array and put all the values in. So it would end up with something that looks like this, if you did that. So that's a good thing. The other one that's good here is replace. So take the old character and replace it with this new one. This replace 1, the very first occurrence. Replace all. Obviously, we replace all of them. Is empty, Boolean, remember, is. That says if the string has any characters in it or not. Prefix starts with. So does this thing start with? Give me all the words that start with the letter T. So for example, starts with. Ends with, suffix. Give me all the words that ends with the letters LE. To uppercase, put this together. To lowercase, important. Change all the characters to uppercase, change all to lowercase. And trim, remove all the white space, any space in front and behind of the string. Take them off. Okay, so at this point, what I would like you to do is pause the video. And using only the class description to write these sentences. So the class description, along with any of these methods, substrings, character at, to write these sentences. So what you need to do first is you need to make a note of this, okay? And you see how this is done. So write this down. Write down the geometry is a good class. Make sure you pay attention to the space and label everything. Write down the visualization here as well for substrings. Okay, so you put the line between and you label the bars and you label the letters up here. And then you use that information to write class dot substring 58 or whatever you want and come up with these sentences. Okay, so you should actually be pausing the video at this point and working through these 5. I did them already and I'll share the solutions in a second. Okay, so now I'm going to show you my solutions. Now you don't have to necessarily have my solutions. You could have any solution you want. See, I did them all. And you'll see them when I post this online as well. So you could see here that all I'm trying to do is to figure out which stuff to use. I'm trying to be clever here. So I went with the substring 9, 10, to uppercase. I'll only walk through the first one and you'll get pretty much the idea. So go to class description, grab this string from 9 to 10 and turn it to an uppercase letter. So let's see what that looks like. So 9 to 10 uppercase. That's I. Okay, so far so good because I want I am tall. The next thing I do is go to this description and go from 8 to 9. 8 to 9 is a space. 8 to 9 is a space. That's what I want. I want I space am. So now I'm looking for AM. So I go to character at 12 and character at 3. So let's look at that. Character at 12 happens to be, I gotta look up here, character at A, and character at 3, am, I am. Have that already. Now I need another space, so I've got to do the same thing again. I say character at 8. Alright, and I did that just to show you a little versatility here. Character at 8 is a space. So now I have my space, and then the last thing I need to do is tall. So I go character at 5, 12, 20, 20. Let's see if that works. 5, 12, 20, 20. 5, T, 12, A, 20, L, L. See that? I am tall. So I'm going to run this, and you will see all of my prints down here. There we go. I am tall. Try to get a good rest. Meet me at class. It's hardly a game. I am last to get retro style. Now, let me just say something about the methods that I spoke of before, the ones that are not on the AP exam. So you see, I say 2 uppercase sometimes. Yeah? I also said 2 lowercase because maybe I wanted to use the G, but the G was uppercase and I wanted it to be a part of a lowercase word, so I had to go to lowercase. And I basically used just substrings and character at to come up with my answer. You could do any variation of this. I suggest you walk through and make sure you do them because, as I said, they're going to show up on quizzes and you want to be practicing these things. And last thing before we wrap this section up is to convert. Now, I showed you casting. I also showed you string that value of, but I want to reiterate. I want to do it again. So here, we have a string conversion for the value here. Now, I'm going to print them. So system dot out dot print. So I can say string dot value of. Now you realize that value of is overloaded. Look at all of these string dot value of. You could put in an array, you could put in a boolean, a character, a double, a float, doesn't matter. It just could take anything. It even could do an object. So I'm going to go ahead and say value. And it would print value as a string. That's good. So now, system dot out dot print value dot toString. Now this is not possible. I showed you it because you cannot do it for a primitive. So cannot use toString on a primitive, only an object. Make that note clear, so I'm going to comment this out. That's not possible. You have to use toString on objects. So if you have objects, you can use both. If you have primitive, you could only use this first one, string.value of. So that's what I'm going to do. I'm going to go ahead now, and I'm going to do these. Same thing, okay? So here we go. I'm going to print these as strings. I'm going to print them, but I'm going to print them as strings. And why am I doing this 3 times? If you're wondering, it's because I'm going to show you 3 ways. First, you could just put the actual object in. Second, toString. See, it comes up from the completion. Or could say string.value of. One of the things I don't want that string.value of. The API always does this. It tends to think that it knows what you want. Okay, so now look at this. It says I have 3 ways to do this. You pick one. Once it's object, flexibility, flexibility. Remember that. Oh, here we go. Non-static call, non-static call, static call. I'm going to repeat these things so you could drive the point home. Static call, string.value of, non-static call. Created the instance, call the toString. Oh, what about this one? Oh, this one is the second one. Computers have a way of doing things called default value, default thing. By putting this in here, you are calling its toString. So it puts the toString on here and does it for you. So if you have an object, you don't have to type .toString. You just put the object's name and the system will put the toString on and turn it into a string. All right, let's try doing these ones then. These guys down here are also objects. Okay, so that means I could do this 3 ways. And you should get the picture at this point. I could just put the price in. I could also put the price in and say dot toString, because it's an object. And I can also put the string dot value of. So that means you could find a way to write or create strings. Let me do one more. Let me do it in a other way. String age string equals to string dot value of age. Okay, and I'm gonna say string age string 2 equals to age dot toString. And I know in your mind you're thinking string age string 3 is equal to age, and look at that, we get an error. Okay, we get an error. I had to show this because I don't want you walking away with the wrong idea. The reason why it worked up here is because we were printing it. It's specific to printing, not assignment. Okay, because I'm printing it, if I put the object inside the print, it calls its toString automatically. Do not confuse that for assignment. I can't assign age, who is an integer, to a string. I got to convert it. But I could print the object in here as a string because it's going to convert it for me. I know it's kind of weird. Sometimes it does it for you, sometimes it doesn't. So I got to pay attention to those technical details. This is not possible. If you want to turn it into a string, that's the way. Say toString. Say, hey object, go to string and let me save you as a string. All right, I'm going to run this, see what we get. I'm going to tell you right now what these things are. I'm going to print the last 2 things. Let me just print them. So I'm going to print age string, put a space, and age string 2. Just so we can see what happened. I'm going to tell you. These are going to print, they're going to print some hexadecimal stuff, which is supposed to be some code for their memory address. And you'll see at hexadecimal number. So I'm going to run this, check it out. These are the things we had before with your points or NAND. Okay, we expected a NAND because we were writing it for just quadratic that works. And here's my 24 for my string, glass, try me. The odd was not present. It's true that the strings were the same. We had the 0 substring and the 0 to 24. We had the comparing. I am tall, try to get a good rest, meet me at class, and so on and so forth. All right, and then we had this 10. Now we realize the string value of it printed 10. And then here we go. See this hexadecimal number? How do I know it? This E. So what is a hexadecimal number? It's a number that counts from 0 all the way through 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it goes 10, 11, 12. But the 10, 11, 12, it starts with A. A, B, C, D, E, F. A being 10, and B being 11, and so on. And you could see here it printed the value for the price. So if you don't have a toString setup for your thing, it's going to get you some hexadecimal thing. And here's my price, and here is my age. Okay, so this brings me to the end of 2.6. Go back up to make sure. This was a long section, a lot of stuff. Very important section though. 2.6, 2.7, huge section. I'll suggest you really sit down, work through this, do it again, check it out, study this deeply, because strings are a huge, big part of the course. So if you're finished with it and you have to do it over, I suggest go ahead and doing it. And also, take the strings and really try to write these or make up some sentences of your own and see if you can do that. Just get used to doing all of that, because the more you practice, the more you deal with strings, the better you'll get. And doing that requires some algorithmic thinking at times, as you'll see later. So the earlier practice is going to be fruitful. So go ahead and do that. And again, we're at the end of 2.6, 2.7. It's a wrap.